Hi, my name is Zainab, and today I will be talking about natural products as biomarker tracers. First, I want to go over some definitions. First, I want to talk about biomarkers and what they are. Biomarkers are characteristics of any biological state that can be measured. The term biomarker evolved from early product precursor relationships and was proposed in the 1960s. Biomarkers are defined as compounds derived from biological sources. This is what I will be mostly focusing on. Biomarker tracer is a substance introduced into a biological state or other system so that its subsequent distribution may be readily followed from its color, radioactivity, or other distinctive properties. The use of biomarker tracers can range from medicine, pharmaceuticals, geochemistry, botany, geology, and other branches of biology and chemistry. Most biomarker tracers are derived from natural products, and today I will be mostly focusing on a few natural products as biomarker tracers in geochemistry and environmental studies. So here I wanted to include a list of natural products as biomarker tracers and their origins and their detection methods from one of the studies that I used. So first I wanted to focus on higher plant biomarkers, which kind of comes in two categories, lipids and biopolymers. Lipids includes terpenoids, homologous aliphatic compounds, and biopolymers includes lignin, cellulose, and hemicellulose. First off, higher plant means higher order plant or vascular plants like angiosperms, gymnosperms, or ferns. Biomarker lipids can carry strong carbon number prominence inherited from biosynthesis and their homolog I can't say that word because of my accent, but I think it's gonna be fine. Homolog distribution can and their homolog distribution can reflect biogenic origin, like if they're marine or terrestrial vegetation. They are the biomarkers derived from higher plant baxes most of the time. This is especially true for lipids and aliphatic compounds in particular. The major application for these biomarkers is in studies on diagenesis of sedimentary organic matter to supplement the aliphatic biomarkers, and in studies of environmental contamination by fossil fuels and by eroded sediment that contain those tracers. So it kind of basically means that they are mostly used to figure out contaminants if things have been contaminated by fossil fuels or eroded sediments. It's just kind of a fancy way of saying all that. Here I wanted to talk about homologous aliphatic compounds, which are basically alkanes, alkanols, and alkanoic acids. And here's a short list of some aliphatic compounds used as biomarker tracers in sediment samples. So they're used because they have a strong carbon number prominence that are inherited from their biosynthesis. They're derived from epicuticular waxes, which is in the plant and related lipids of high plants. The biomarker traces usually contain about 24 to 30 carbons, and that is the more preferred uh, compounds used. The homolog distribution can reflect the biogenic origin of natural organic matter. Alkanes, alkanes consist entirely of single bonded carbon and hydrogen atoms and lack any other functional groups most of the time, especially for these biomarker tracers. Alkanols are aliphatic alcohols. They represent a family of organic compounds containing one or more hydroxyl groups bonded to an alkyl group. Sorry, I hope I'm saying that right. And alkanoic acid is alkane-derived compounds that contain a carboxyl functional group. So, in this slide, I want to talk a little bit about terpenoids and what they are. Terpenoids are natural products derived from reductive and oxidative alterations of the precursors. Here in the figure, you can kind of see the precursors and kind of what kind of terpenoid they turn into later. Usually they use triterpenoids and sometimes tetraterpenoids, but mostly they use triterpenoids and tetraterpenoids. I think I just repeated myself. The figure represents alteration of sesquiterpenoid precursors to saturated and aromatic hydrocarbons. These natural products are used as biomarkers to identify terrestrial organic sediment or the atmosphere, basically. Oxidative alteration occurs mainly by successive ring aromatization that usually commences from a ring which has a functional group by a direct dehydration, ring rearrangement or ring opening, and subsequent loss. And usually the steroids used in biomarker tracers are derived from terpenoids. Because I'm mostly focusing on geochemistry and environmental studies aspect of biomarker traces rather than other forms, I want to talk a bit about petroleum biomarkers because they're kind of important in my presentation. I mostly did research on more geological studies and geological journals and articles. And I came across a lot of articles about petroleum and oils, gas, and other fossil fuels that we use. And there is a lot of study on them using biomarker tracers to kind of find out what's in them. So here are 3 of the petroleum biomarkers that I have found. So there's hopanes and they are molecular fossils of bacterial lipids that adjust membrane permeability and fluidity. And they're mostly like very old and not a lot around. So yeah. And tricyclic terpenes are I just, well, I can't say are, but like, I just couldn't find a lot of data on them. At least not a lot that I would like. So I think I'm just gonna skip that one. And steranes are derived from steroids or sterols, and they're used as biomarkers for the presence of eukaryotic cells within the fossil fuel. I want to talk a little bit about applications of biomarker tracers. So, because I'm mostly focusing on geochemistry and environmental studies, I wanted to focus on application in those fields. So, biomarker tracers are usually used for identifying organic terrestrial detritus like the atmosphere or sediments in oceans and other marine environments or sediments in terrestrial environments. They are used to study carbon export by rivers to the oceans. They are used for identifying sources of petroleum. They are used for paleo, environmental, and atmospheric research. And they are used for they're proving to be useful tracers for atmospheric and sedimentary particle sources and transport in our world. Any questions? So this is my dog, Cougar. He's very nice and he's very lovely. He always looks a little depressed and shy. And here are the sources that I use. I mostly used geochemists articles. So yeah, thank you.